So we are here today to talk about Vertex AI and pipelines and how amazing are these things. So it will be a short presentation, about 25 minutes, and hopefully it will be interesting for you. A bit about me. I'm in cloud development, but also very active on contributing platforms like StackOverflow. So I contributed a lot there, and I answered a lot of questions. So I got huge reputation points. And maybe you have found me on the Pentium 10 username. All my articles are on Medium, for example. There is not a paywall there, so you can check it out. And the presentation will be uploaded shortly after our session to SlideShare. You can find it by the Marton Kodok username. My day job is about running databases and machine learning work. So here I'm going to show you something as amazing about Vertex AI. We are going to see what is MLOps, or what is Vertex AI, how to build, train, and deploy models. Then we are going to see pipeline-specific items and anatomy of a pipeline, and how do we react to changes of data and to kick off our pipeline. Those are actually interesting things in the Google Cloud Platform. So, first part, what is MLOps? MLOps could be something like DevOps principles to machine learning systems. So it could be a definition that would help for you to understand what is MLOps. But if we look at the elements of the machine learning system, we have all kind of feature engineering, data collection, even model analysis, but we have serving infrastructure, we have monitoring as well, we have automation, configuration, and all these should be connected together in a pipeline when you actually develop machine learning code. We will see how to accomplish that. And if we give another definition to MLOps, it's a continuous delivery and automation pipeline for machine learning system. You need to understand and probably have started using pipelines, or you are running, let's say, a manual job for a machine learning system. But the true level is that when you run together with the continuous integration and delivery of your code to automatically replace the models of your system. So, if we need to have a quick overview of levels of automation that defines the maturity of the machine learning process, we could identify 3 levels. Those are manual process, when you trigger some building, training, and deploying some model manually. Then there is the pipeline automation, when all these are happening, and there is the CI/CD automation. If we want to expand more on this, we are talking about a manual process when we are deploying models entirely manually. This is something infrequent. You are not doing, let's say, every day, every hour. And there is a disconnection between machine learning and operations, like operating your infrastructure. If we go to next level, and if you advanced in your organization to this level, that's extremely helpful, and it's extremely good. So you have a pipeline automation, you have a continuous training of a model by automating the pipeline. So actually you trigger the pipeline, and the pipeline will do the continuous training of your model. So here you have a delivery of a model prediction, let's say a prediction service, but you have a continuous delivery, and that's important. Then new pipelines mostly are based on new data. So whenever you find out that there is a new data or something have changed, you could trigger your pipeline. This is called level 1 pipeline automation. And the level 2 automation is that when you are developing and you are actually iteratively try out new machine learning algorithms and modeling. So the experiments are orchestrated, which means that the output of this stage is the source code. So it's important to understand that the source code can be built, can be changed by adding hyperparameters, by adding evaluation decisions, and the source code is the first output of this pipeline. Then the source code being pushed to a source repository is being built, and then you are running the test. If the test succeeded, the output is actually a pipeline definition. We are not talking about pipeline running here. We are talking about defining the pipeline. And pipeline defining is the level of automation introduced by the level 2 automation. When you have the pipeline definition, you fall back with level 1, you trigger the pipelines automatically. This sounds, let's say, theory. Let's see in practice how actually these are piped together, because level 2 pipeline is the most complex example that we are living these days. So let's say on the bottom, you have, for example, a manual process to train a model and let's say deploy a prediction service. This could be, for example, your 2 manual processes someday, but then you get into automated pipeline. Automated pipeline has a new data. The new data is being obtained by the continuous training and it retrains your model. You have a model version 2, version 3, version 10, 20, and so on. And the model is continuously delivered to the deployment, to the endpoint where you are serving your model. This could be another level. Then, if you have some way to run development and experiments, and as I mentioned before, level 2 is actually running these experiments on your models, actually obtaining, monitoring the model, and those information to feedback into development and experiment, you could generate a source code. But the source code is a pipeline definition. So people ask me, what is the source code? The source code is a pipeline definition. Then the pipeline is being packaged together in order to be automatically started. This is in a nutshell the pipeline automation. If we want to separate the level 0, level 1, level 2 elements, I could say that level 0 is here. Level 1 is these parts, and level 2 is when you actually generate the pipeline definition and you package the pipeline in order to be automatically executed. Now, for this, you need a platform. And the platform I'm going to talk about is Vertex AI. Vertex AI is a managed machine learning platform. Managed means that it's run on Google Cloud infrastructure. It's a service where you don't need to get a hold of a server. You don't need sysadmin to install stuff on the server. It's a service put together and you are paying by the usage. So it's for practitioners to accelerate experiments and deploy AI models. So in here, we have the basic stuff to deploy a model, but also to build, train, and all the stuff fit, but also to accelerate experiments, because we are talking about pipeline and we are talking about releasing models as frequently as the project defines. It could be multiple models per day or per week, or based on a data change or an event change of a model. What's included in Vertex AI? Vertex AI is very stuffed and a lot of stuff is being added to the Vertex AI product platform. But essentially the process is that the data readiness defines the feature engineering. Then there is the training, then the model, essentially understanding what we have built out, there is the monitoring, and then the management. The basic stuff that every ML practitioner is looking to achieve. Then there are the AutoML product of offerings, where these are pre-trained models and managed models by Google platform. You are able to obtain from these categories multiple models, like each have around 5 to 10 options of these categories. These are just the categories of the AutoML pre-trained models. Then there is the custom model, and mostly on conferences, people look to define their own custom model, which can be done easily in Python or in plain containers, whatever you put in your containers. Then there are a bunch of services in order to run all the pipeline operations and all the machine learning stuff, starting with data sets, by training, by having a model, by deploying the model to an endpoint to get, for example, a prediction. And all these can be run by a pipeline orchestration. Of course, there is a notebook service as well in order to have you fast environment. And if you want some deep learning environment, it's offered that as well. My favorite is actually Feature Store, where you are able to compile data sources, and this Feature Store automatically recompile the data from a third-party system or from a database. This is one of my favorites. And metadata service. Metadata service is something that I'm able to create variables, diagrams, all the artifacts of the model, and I can store it on the Vertex AI platform. And by storing there, I get actually monitoring help, and I get, for example, advanced features like explainable AI or AI accelerators or Visier optimization. These are products that each could have a full day of conference to understand what those are. Google it up, try them out. These are amazing. Now, Vertex AI is a serverless platform. So we need to understand that it's serverless, so it has an operational model, but on the programming model, basically it's not a website. So the model is a service. So instead of building a website, we are building a model. And we have open SDKs integrated with ML framework. There are 5-6 frameworks from TensorFlow to PyTorch to Scikit, and all the frameworks are operated on Vertex AI. Now, part 3. And part 3 is actually our today's most of the today's topic. So here we are going to talk about using pipelines to put all these elements together. So if I refer to back, pipelines we had identified on this chart are here. Sorry, I'm jumping here. So why are pipelines useful and what we can achieve with them? Essentially, we can orchestrate, we can adopt MLOps and develop steps independently. So I am going to actually see and show you adopt MLOps for production models. In case if you need repeatable, verifiable, and automatic process for making any change to a production model, you need a pipeline. That's a framework, that's a standard. Also, as you scale out, if you build out a specific steps with your team, like only obtaining the data, you can have that as a step in the pipeline. And then they can run it and contribute code only to that part. So it enables you to track the input and output from each step in a reproducible way. That's are the pipelines. Literally, when we are on the Vertex AI interface, we get a visual of our pipeline with our artifacts as well. In the code, this is, for example, a code where we are training something with our own functions. It's not using AutoML, and it's a simplified code in order to show you how the pipeline definition is. I'm taking from the bottom of this. So the pipeline execution is done by a JSON specification of the pipeline. In order to have this JSON built, either we run it manually or we build it with an automation process like cloud build. Now, to build a JSON, this is the code where we build the pipeline definition in a JSON. We need a pipeline definition with a decorator. And that decorator is here. So essentially, you need a pipeline route, a name for the pipeline, and then you get the pipeline definition. Each step is here. This is a simplified view, like obtaining get data. This is a function to obtain the data. There is a train step here that uses a dataset train artifact as an output. So you are able to see, for example, this little icon here is the dataset output. And then the eval model is actually using two inputs here, which are the tests and the model as well. So sorry, I've shown you wrong. The dataset train is from here and evaluation from here. So you get the data, but it's separated into train artifact and evaluation artifact. The train artifacts runs on the training, it produces the model, and the evaluation function uses the eval dataset and the model definition to produce additional artifacts. This is the basic of a pipeline. It's very easy to define with a decorator. This example is based on my fellow GDE, Piero Esposito, and you have here the link in order to try it out. There are tutorials how to run this on your own instance in a notebook. Now, so we have get data train model, but we need to do deploy model as well. Deploying a model is on an endpoint. This is another example where we have used components from the pipeline, from the Google pipeline components. I name this as a pipe operator here. These platform components let you, for example, automatically train on AutoML syntaxes. So, for example, you have dedicated functions in order to run an image dataset creation and then to actually have a training job as well. Also, compiling and running the job is the same thing. You compile a JSON, you run in a JSON as well. This is another example you can find on the GitHub. You get it, and it's a full notebook that you can run on it. Next. So I'm going back a bit here. Model deploy here is actually deploying to an endpoint. And I forgot to mention that here we created an endpoint. This is like a REST API endpoint that you have created. And under there, you are able to deploy your model. It's very interesting way. You get a HTTP endpoint where you can authenticate the way to ping and run your evaluations, run your prediction, whatever machine learning job you have built out from there. And as this is an additional step of it, you can have here much more complex pipelines. You can, for example, train based on some parameters like train for mobile devices, train for desktop devices, deploy different endpoint models. So adding there 5, 8, 10 steps is actually a code that you can add in here. Now, based on evaluation, we can actually deploy a certain model, which is important to understand, but there is a training job. But the training job, this runs, let's say, constantly, and it produces 20, 30 models for you. But which one is successful? Which one is better than the other? That's why you could have a function where you deploy, and this is the deploy. This is a conditional on the model. You deploy only if some flag is being, it lets you to deploy. So what you see here is that we have the pipeline definition, but here there is an operation, which is a condition. And if this decision flag is being true, then it executes the two other steps, like creating the endpoint and deploying the model as well. It's very interesting and it's very powerful. Among the condition, you have also parallel executions. And if you look up the definitions for that, for this domain-specific language, you are able to find this, the operations which you can actually add features to your pipelines as well. Now, these provide developer-friendly components that lets you actually to build custom components. If you have functions, you can share component specification. You can, for example, externalize a recipe of a component and then load from URL from a different project across the project in your organization. So all these are developer-friendly components. So, recapitulation, what we have here is that we touched all these elements of the Vertex AI platform, but we are going to go next. We are going to adapt our pipeline to changes of data. Let's see how we accomplish that. When we are talking about automatic CI/CD perspectives on GCP services, we can have three sources of truth, let's say so. The cloud scheduler is the easy. We poll for changes of any data based on a schedule. You set up a schedule like every night, every morning, or once a week, start a pipeline. You could, for example, start another product service, which is called Cloud Workflows. Cloud Workflows gathers all the data and triggers the Vertex AI pipeline. So it's an amazing feature to actually combine the scheduler with a workflow service to trigger the pipeline. This is a fixed and based on schedule. What if we have a change in our code base? If you have a change in our code base, let's say on a Git, we can actually react to that. So if someone pushes a new commit or a new branch, whatever, it can, based on GitHub Actions, trigger a cloud build. It builds out the pipeline specification. The pipeline specification is placed on the cloud storage, which is the, let's say, S3 similar on Google Cloud Platform. The image being built to cloud registry, and then it will automatically trigger the AI pipeline. The pipeline can use AutoML features, but can use also containers which you have built out using the cloud build. This is an amazing service, and this lets you to react on changes in the code base. But next, if we talk about the Google Cloud Platform ecosystem, you have EventArc, a new product offering. EventArc is an event-driven system, and it detects events on your platforms, on your cloud system. So it detects changes on data or changes on services. You drop a new file, a new folder is being created on cloud storage. You set a label on something. You get a pop-up event on a specific topic. All these are GCP services. So it handles the events. And for example, you can put that event in a cloud workflow environment or a cloud function where you have code that generates the specification or reuses an existing pipeline. And it triggers the Vertex AI pipeline definition, which means that in a nutshell, whenever you see a change, either on a code base, you have the way to, with Cloud Build, to trigger the pipeline with the code refreshed, or trigger the pipeline based on some event in your other services, or storage, database, other services on the cloud, and trigger the pipeline, trigger retraining the model, eventually aim to build out and have a better model in your system. The Pain scheduler lets you to actually run that on the old legacy style of the system. Conclusions. And while I'm saying this, if you have any questions, please type in the chat. I'm happy to answer it. So, conclusions. Vertex AI is truly an enhanced developer platform and it provides you great experience. You can build with groundbreaking machine learning tools that power Google. It's approachable from the non-developer perspective as well. It has AutoML, which is a low-code integration. It has managed models. You just play the model and set the variables, the options of the model, and it automatically lets you to train the platform without setting out any infrastructure behind. It eases the life of a data scientist because it has feature store. It has managed data sets, so you have a place where you to store all your data that you have put together, either on disk or in databases. It provides you endpoints, which means that you can deploy your models as a REST service, and these endpoints are automatically scaled. So it scales to 0 as well, but also can scale to hundreds and thousands of requests. It has end-to-end integration with build pipelines, whatever those are. It could be based on code base or on events. And it lets you to do GitOps style continuous delivery with Cloud Build as well. And for very advanced users who want to actually go on steroids with the machine learning models, they have integration with explainable AI and TensorBoard to visualize and track machine learning experiments to see much more clear the path to your better model. So thank you for having me here for this amazing Friday. And hopefully you found my presentation really amazing. And if you have any questions, please post in the chat in order to answer it. The presentation shortly will be uploaded to SlideShare, so you are able to rewind and see all the elements and all the GitHub links which I added in there. And you can reach also by this username on Twitter or on LinkedIn. You can find me to chat in individually. Thank you for being here.